Antoine Faddoul.
Thank you, and thank you all for being here. We're going to talk about space architecture designed for human extended space missions. All right. To build a starship for the future, we need to know what's going to happen on a starship in the future. So, Starship Lena, the date is November 1st, 2112 on Earth. It's November 1st, 5 a.m. simulated time, 12 years after Starship Lena left the lunar orbit. It's heading to exoplanet Antis and Cygnus, traveling at speed of about 6.7% of speed of light. 7.5 light years are left to destination. Population of the Starship is 1,042. Every 5 a.m. on simulated morning on Starship Lena, a long checklist for hundreds of thousands of items are checked for structural, environmental, and for human inhabiting the Starship. Checking what's going with each one of them. We're gonna go over only a few of them to see how that affects our design concepts. Engine check, the shield with a dust shield, radiation shield, energy, maintenance. You can see 282 auto replacement happened. Equipment, 12 were replaced, 4 recycled. Gadgets, 30 replaced, 18 new. 2 repairs in the subsystems. 20%, vegetation is 20%, providing now as part of the food and nutrition system. Population, we have 1 newborn in the past 24 hours, 12 over a year. Security, we have some large groups, or people are grouping in groups. Physical status, 3 people did not report to work. And we have 2 depression conditions, 6 undeclared. So basically, if we look at what we have, or what we can conclude from here, we can see there are several design aspects that are needed in space architecture for a starship. From simulated day and night, propeller, radiation protection, reliability, robotics and automation, 3D printing, air system, water system, circulation, destination, food and nutrition, navigation, communication with Earth. And if we concentrate on the inhabitants, we can see more happening over there. So we'll put a little bit better environment here for the people. And the report said that people started gathering in groups or saying individually, which make them, actually that's also caught in the last element of the mental status. People are also getting depressed, and normally they either go join people in group or stay apart. Other thing that also we need to think about here, when those people left Earth 12 years ago, they were wearing their clothes and fashion like we do right now. They were not like in one of those sci-fi movies where everyone's wearing the same thing. But about 12 years later, they tried actually to care less about what they were. They tried to, they almost wearing the same outfits, or mainly it's not, being fashionable is not that important for them anymore. Another thing, we can notice that we have 1 newborn baby, 12 in a year, but in the past 12 years we only had 42. And that's another thing that might face the first generation who's trying to adapt to a long trip. We're talking about people trying to start families or have kids. Normally they don't do that if they are on the road, or they are still traveling. They need to settle more before they do that. And it looks like for many on this starship, they didn't feel that they're actually settling. They still feel that they are on a trip. And we have to keep in mind that when the starship left with 1,000 people, about only 300 of them were actually scientists or in the field of space and space travel, which means those guys can put up better than others who went with the Starship population, and will have better expectation of what could happen in space, how to cope with being away from Earth, and how to deal with things than the other people who joined. There could be anything from educators, farmers, mechanics, or any type of life we need in society to make a full society. And from this also we can derive several other aspects in design. We talked about fabric and clothing. We spoke about landscape inside, G0, Generation Zero, adaptation to what's happening, parenting, nurseries, policing, healthcare, daycare. And to go of what it takes to build a Starship, I went actually over 100 elements for what's needed for deep space travel. Anything we think about that for a Starship, which basically taking a structure that's close to Earth, traveling at hyperspeed to a place that we don't know yet, and going to take several years to know, and using technology that we don't even have now. So we have to consider all that while we're talking about the elements of design, whether it's an engine, a radiation shield, a water system, a sewer system, refrigerating, food and beverages, socializing, sports, arts, children, education, generation 1 adaptation, new generation in space, storage, communication with Earth, time delay or time dilation, policing, government, all that. I mean, this is how it looks like when you look at it from an architectural point of view. Most people here are engineers. That might be a little annoying, but that's how things come to one's head. And certainly we're going to have to classify those items to see how they work and where they are in, what stage they are in design and in technology and what's happening to them. And that could be, we can break the elements basically into 3 major categories: structural, environmental, and human aspects. Each one of them accounts roughly to 30% of the total 101 items. Now, to put it in a better picture, each one, this is better organized. I'm not sure if you can read it or not, but basically each one of the 100 items, we're looking at the human aspects here, about 30 or 31. Each one of the items, if you see the final here, destination is Interstellar, but whether it's a mission to the moon, to Mars, to one of the outer planets, moons, Pluto, or Interstellar, or whether it's colonization on the moon, Mars, outer planets, or Interstellar. If we go to Interstellar, all of the 100 items are required. If we go to other type of missions, some of them will apply, some of them will be required, some of them have medium requirement, more or less. So it depends on the trip. Also depends on the type of the mission. For example, a mission to Mars won't really need much concentration designing for aging in space, but settlement on Mars were required. So basically each one of the elements was analyzed and was assessed to where it fits and where it's needed in a comprehensive way, so that we know what we need for a full trip and any phase before that or any other destination or mission will need part of it. More assessment was carried to see what's happening with each of those elements. Is it current technology, is it developing technology, or it's future technology? Some elements, like in the structural part, are more tested because mainly we've been sending structures to space. We even send them to the edge of the Milky Way, but that doesn't mean that the current technologies also can be used as heritage or as is. We need a lot of development to make it go to or be applicable for interstellar travel. But also cannot be part of the future or things that are still in theory in the structure are less than in environmental elements and are way less than in human factors for inhabitants. Basically because we have some close environment, our big or our main experiment there is in the ISS, though it's Earth dependent, because we always have supplies and shuttles coming up and down, or going up and down, and the other closed environment, or even with the inhabitant, would be like the crew trips to the moon, which were very short ones, about 10 days roughly, with 2 or 3 people in a confined place with minimum requirement. They're going to be back, so they didn't really work on resolving a lot of the requirements since it's a short trip. I like to show this mainly to show that our human travel or human space travel is actually like between the ISS and the moon, which is only about 400,000 kilometers, while even talking about Mars, Mars on average is about 140,000 kilometers, but even when it's closer to, 140 million kilometers away, when it's closest to us, it's about 50 million. That's still way further than anywhere we've sent humans to. Now, talking about design. Design mainly is what we can make out of function, budget, aesthetic, and life cycle. That's how we design everything on Earth, whether it's a structure, vehicles, furniture, and that's the same way we can design things for space, for spacecrafts, and for the environment inside and whatever we're going to use there. An important point that we can talk about is sustainability, and when we're designing on Earth, it's very simple. We have to use less, not deploy natural resources, recycle, reuse, and be self-sufficient as much as we can. Going back to space, we don't have options. We must use less. We don't even have anything called natural resources. Resources are whatever we take with us. Recycling become a must, so as reusing and self-sufficiency is not an option. It's the only way we can survive it till the end of the mission. And in extreme space, an extended space mission, time and distance they become really extreme. First of all, even anything dependent on energy like we do on Earth, even renewable energy such as solar, wind, geothermal, they don't exist. They only exist here on Earth because of Earth itself and its location from the sun and or the solar system, and certainly raw materials don't exist at all. So we have to count on that when we're designing, and also make up for any development that's going to happen later in deep space. So there are a few non-traditional aspects in designing. First of all, when designing for space travel, the market normally is aerospace engineering driven, while we need to concentrate more on the holistic design, where we have an architecture design including everything and accounting for the aerospace engineering as part of it. There are uncommon architectural research methods. When we research any project right now, what we do is that we check what we need to have, the program, like the 100 points we got over here, and we also check any previous work. We don't have much previous work, and the research become a little bit odd here in space architecture. We're looking for experiments. Some people are experimenting on some propellers. Some people are sometimes we have to wait for probes. Like the data we have about the radiation from here to Mars, we got it from the spacecraft that arrived there in 2012. They sent it back to 2013. We got the result 2014, and that's the only data actually we know about specifically what type of radiation we're going to be subjected to in a trip from Earth to Mars. There are different teams working on different parts of the project, like people here working on propelling engine. We have people working on the social environment, only a few of them, like the Biosphere 2, like Mars 500, checking what could happen to people in such environment when they are enclosed and away from everyone else. Design transdisciplinary is required. People have to be a little bit more knowledgeable about what's happening with the material, what's happening with the propelling, what's happening with every aspect. Some of them are social, some of them are scientific, and that's more involving than any normal design project. And also have to account for the microenvironment and the macroenvironment. If we're designing a structure on Earth, like for this building, we know it's part of a macro environment, like the buildings around you, like the city around you, where you can interact and get whatever you need from the city. And then inside here, whatever we're using, data and communication and furniture, is our micro environment. If we need anything else, we have to fix it from here, or we can, again, communicate with the macro environment and get whatever needed. But when you're in space, your system has to account for the macro environment and micro environment and take all that with you to space. I already spoke about sustainability in space. It doesn't change, but mainly your resources do change in space. I'll talk a little bit about macro environment, just giving an example of what do we have to include. If we're just designing a house, the house is part of the town over there. We have the farmers or the farm. You can get some products and can prepare some food. Your microenvironment will be designing the kitchen inside, and then you can bring the food from outside. You can have a meal, and if you need anything else, you can bring from outside. That's the simple way. Now, if you're on a starship, your microenvironment is also the starship, and inside you need to build your kitchen, you need to get your food, you need to get your cultivation, your soil, your utensils, your pans, everything you need for now and for generation to come until the mission is over. And that's not only, that doesn't apply only to the simple food example. Let's say you're just going there. Well, don't forget to take the air you need to breathe. And while taking the air, it doesn't actually stop at the air you need to breathe. There are a few other things you have to take with you. The human biome, whatever bacteria, whatever microbes living around you or inside you, you need all that actually to sustain life. You have to take all that along with you. And that tells us how much we have to account for in a design. So if you have to take the air with you. If you want to play any sports, you don't have to take only your golf clubs. You have to take your golf course. Healthcare, you can't just go to the doctor, or they have to take the doctor with you. Whatever equipment they need, whatever medication, whatever material to make the medication, whatever we need to use to extract material to make the medication there. And certainly if it's a multi-generation trip, you can also have to take whatever you need to educate new doctors to do the whole cycle. And things continue there. Now, human factors, major human factor that we need to account for, sometimes they overlook or sometimes they just ignore for a short while. Physiological, psychological, and social. Physiological, you can see most of them are the first part for vision problems, cardiovascular, musculoskeletal, and neurosensory. Most of them actually come from being in space, mainly those in microgravity, and I think most of that could be overcome generally with a generating gravity on space or Starship. But even those elements in today's trips, like trips to the moon, they were sort of postponed. They postponed actually dealing with them because they were for a short while, because they're going to have a little bit of bone loss or muscle loss. So only 10 days when you come back, you can exercise more, or before you go, we can give you some countermeasures. Psychological and physiological, as I mentioned, we don't have many studies, but the Mars 500 system that simulates being on Mars or in close environment. Last experiment, I think, finished earlier this year. They had about 7 people there for over a year and a half. And the Biosphere 2, basically a few things are concluded from there that affects everything and the design for people going on a interstellar mission, like depression, stress, and other activities. Now, things like loneliness, confinement, stress, and depression affect not only 1 or 2. We're just looking here how they affect almost 20 of the 30 elements of design we have here. And that's what we have to keep in mind when asking questions about each element and what we're designing for. Now, another thing we have to keep in mind, we're in a multi-generation, we're traveling for like good tens of years in space. Several other aspects of society and culture can develop in space. I just selected a few of them: art, economy system, education, encoding. Some of them were not developed right away. It depends in several aspects such as population size, the social background, crews versus inhabitant. Again, we're talking about how big the part of the population, or small, on a starship that's actually already is equipped and trained for space travel versus people who are just equipped to do what they do in their normal social life, and certainly the duration of trip. And any of such evolvement or development in space happened at two levels, or actually comes from 2 points. One of them, whatever was going on with them when the mission started, in addition to the developments that are gonna occur on the spaceship itself. So we're gonna have like a miniature society developing on its own. If we have two starships living at the same time, each one of them is gonna develop its own kind of society, and with all aspects of societies, what could happen there? We could have two different generation or two different type of communication inside the societies. And I'm gonna wrap up here and talk about what we need basically, or some of the points we have to always keep in mind while designing for space travel or interstellar space travel. We always need a holistic approach that actually can comprehend everything. We have to account for futuristic events, what's about to happen, future scenarios, what we don't need now, but we might need in the future. Also, we have to keep in mind that the development won't stop, whether it was technological development. 10 years from now, we don't know what's going to happen on Earth, but if we have 10 years from now with the Starship leaving right now, we don't even know what's going to happen technologically with them on board. And same thing applies to social and psychological aspects and factors in space. And that will always be the combination of what they have on Earth plus their experience in space, versus what we have on Earth is only, we're going to keep evolving with what's happening around on Earth. Design for macro and micro environment is a must. We have to account for everything. And finally, we have to keep updating. Everything is changing, the requirements are changing. What's required for a settlement on the moon right now or 10 years from now might change in 50 years, because what's required there, if we have one settlement in 50 years, we might have 20 settlements from 5 different locations on Earth, which means more requirements are going to change and what's needed there. And now I'll be ready to take questions.